In this session, I am going to give introduction to data structures and brief description to linear data structures. We know that today's computers are very fast. To utilize the full strength of computer, a thorough knowledge in data structure is highly essential one, because a thorough knowledge in data structure plays very important role in efficient program designing, testing and maintenance also. In computer science, so many number of data structures are available. We can't write any program without using any one of those data structures, because some data structures are implemented implicitly during the execution of our program, I mean compilation of our program. For example, when I am calling a program or when I am calling a function, or if a function calls itself, then stack data structure will be implemented automatically during the compilation. The user may also implement some data structures, depends on his requirement. For example, if I want to store an integer value in my program memory, I go for integer data structure. Already I told you that in computer science different kinds of data structures are available. We can classify those data structures into two categories. One is primitive data structure, second one is non-primitive data structures. Primitive data structures are integer, real, character, string, boolean, etc. So I think you are all very well on primitive data structures, because it is available in every programming languages as a built-in data type. For example, in C programming language, primitive data structures are available as int, char, string, boolean, etc. Once these primitive data structures are implemented in our program, compiler will take care of how much amount of memory is going to allot, what are the operations we can perform with such kind of data, and how it is represented in computer memory. So primitive data structures doesn't require any additional effort from the user side. Non-primitive data structures. We can classify non-primitive data structures into two groups. One is linear data structure, second one is non-linear data structures. In linear data structures, elements are arranged in a sequential memory location, whereas in non-linear data structure, elements are distributed over a plane. Linear data structures are array, linked list, stack and queue. Non-linear data structures are trees, sets, tables and graphs. So both linear and non-linear data structures requires some additional work from the user side. That is, the programmer is in the position to decide how much amount of memory he is going to allot, and how he is going to organize the data elements, and what are the operations he is going to allow. That is, user has to decide which kind of data structure must be used in what kind of situation. While choosing an appropriate data structure, the programmer should be very careful, because the structuring the data determines, the organization of data determines the speed of operations such as searching, sorting, insertion, traversing, etc. So now we are going to discuss about linear data structures one by one. Array. Array is finite one. That is, the number of elements in an array are limited during the design of our program. Array is ordered one. That is, all the elements in an array are arranged in a sequential manner. Array is a collection of homogeneous data elements. It means all the elements in an array are of same data type. I think you are all good in array data structure, because it is implemented in every programming language as a built-in data type. For example, in C programming language, arrays are declared as int a of 5, float b of 10, character c of 20, where a, b and c are the name of the array, 5, 10 and 20 are the sizes of arrays a, b and c respectively. Integer, float and character specifies what kind of data we can store on those arrays. So we can classify arrays into three groups. One is single dimension array, second one is two-dimensional array, third one is multi-dimensional array. Single dimension array. If the user uses one subscript or index to to refer an element of array, then it is known as one dimension array. For example, in this array, a of 0 is used to refer the first element, a of 1 is used to refer the second element, and so on. Two dimension array. If we use two subscript or index to refer an element of array, then it is known as two dimensional array. For example, in this array, a of 0, 0 is used to refer the first element of the array, a of 0, 1 is used to refer the second element of the array. Three-dimensional array. If the user uses three or more dimensions, three or more subscript to refer an element of array, that is known as multi-dimension array. For example, in this array, a of 0, 0, 0 is used to refer the first element. Operations on arrays. With the array we can perform traversing operation, searching operation, sorting operation, insertion, deletion, and merging operation. Traversing is nothing but visiting all the elements of the array once. Searching operation is used to search a particular item in an array. Sorting is nothing but elements of the arrays are sorted either in ascending order or descending order. Insertion. For example, consider the array. The array contains 4 elements. If I want to insert an element 9 at a second position, then I need to push down the elements 7 and 8 by one position to make an empty room for the new element to be inserted. The result of insertion array is deletion. Deletion operation is nothing but overwriting. If I want to delete an element at second position, I need to move up elements 2 and 1 by one position. The result of deletion operation is merging. Merging is nothing but it is an operation of combining two or more array into a single array. For example, elements of array A1 and elements of array A2 are merged into array A. So here the important thing is array A should have the enough size to accommodate the elements of A1 and A2. Application on arrays. We can use arrays to store a group of data items. For example, we can use arrays to store the name of all the students in our class, or we can use it to store the enrollment number of all the students in our class. If sequential storage of record is not objection 1, then we can use arrays to store the records. For example, to store the following data structure, record structure, we must use 4 arrays. Linked list. Linked list is infinite one, that is, the size of the linked list is determined during the execution of our program. Linked list is an ordered collection. It means the elements of the linked list are arranged in a sequential manner. Linked list is a collection of heterogeneous data elements, that is, all the elements in a linked list are of different data types. Each element in a linked list is known as node. Each node consists of 2 fields. One is data field, second one is link field. Data field contains the actual information. Link field contains the address of next node in the linked list, that is, it points to the next node in the linked list. We can classify linked list into 4 categories. One is single linked list, second one is circular linked list, third one is doubly linked list, fourth one is circular doubly linked list. Single linked list. So in single linked list, each node contains only one link field which points to the next node in the linked list. Here header node contains null value in its data portion. Its link portion contains the address of first node in the linked list. If we know the address of header node, then we can trace the entire list from it. So from the picture you can see that the link field of last node contains null value. It is just for indicating the end of list. In single linked list, we can move from left direction to right direction. Because of this reason, it is known as one-way linked list. Circular linked list. in circular linked list, last node contains the address of header node. That is, last node contains a pointer to the first node. Here I can access any node from anyone. For example, I can access the first node from the third node. Whereas in single linked list it is not possible, because in single linked list we can traverse in only one direction, that is, we can traverse from left to right direction only. Because of this reason, circular linked list is more efficient to perform searching operation, sorting operation and traversing operation. In circular linked list there is no indication for end of list. It may lead to infinite loop while performing searching operation or sorting operation, insertion operation and deletion operation. Such kind of situation can be avoided by placing a null value in the data field of last node, doubly linked list. So here each node contains two link field. Left link field point to the node at the left side, right link field points to the node at the right hand side. Because of this reason, we can move either in left to right direction or right to left direction. So we can perform searching operation, sorting operation, traversing operation, etc. more efficiently when compared to circular linked list and single linked list. Circular doubly linked list. Here it incorporates the advantages of both circular linked list and double linked list. Here the leftmost and rightmost nodes are linked with the header. If left link field and right link field of the header node points to itself, then list is known as empty one. Advantages of list over array. In an array there is a possibility for overflow because it is finite one, but linked list is infinite one, that is, the size is determined by the user during the execution of program. So there is no possibility for overflow. List requires some additional space to store the address of next element in the list, but array doesn't require any additional space because it stores only data elements. In an array, insertion and deletion operation requires some additional overhead, whereas in list, insertion and deletion operations are performed by interchanging the pointers very simply. Representation of linked list in memory. There are two ways to represent a linked list. One is static representation using array. Second one is dynamic representation using a free pool of storage. Static representation using arrays. To represent a linked list using arrays, we should have two arrays. One is for data and another one is for address. The only condition here is both arrays should have the same size. Here single linked list is represented using arrays. Here one array contains data and another array contains the address of next element. The important thing is size of these two arrays must be equal and it should be enough to store the entire linked list. This kind of representation contradicts the idea of non-sequential memory locations, but this is the one and only way to represent a linked list in some programming languages such as Algol, Photon, Basic, etc. Dynamic representation. In dynamic representation, whenever a node is required, a request is placed to memory manager and it will search for the required block. If it is found, then it is returned to the caller. Similarly, so whenever a node is not required, that is, if it is not in use for very long time, then the garbage collector collects it and return it to the availability list. Applications of linked list. We can use linked list to represent a polynomials or to perform polynomial manipulation or to perform sparse matrix manipulations. Stack. Stack is a ordered collection of homogeneous data elements. In stack, insertion and deletion operations are performed at one end known as top. Insertion and deletion operations are known as push and pop. In stack, the ordering is determined based on the arrival of elements and the removal of elements. In stack, the element which is inserted last will be removed first. Because of this reason, it is known as lost in first out order. We can represent stack using two ways. One is static representation using array, second one is dynamic representation using availability list. In static representation, single dimension array can be used to represent a stack. In dynamic representation, there is no need to check whether it contains element or not before performing deletion operation. Similarly, there is no need to check whether it is full or not before performing insertion operation, because it is represented using linked list. In static representation of stack, overflow occurs when the user tries to insert an element when the stack is full. So the user should check whether the stack is full or not before performing insertion operation. Similarly, underflow occurs when a stack is empty. So the user should check whether the stack is empty or not before performing deletion operation. Queue is ordered collection of homogeneous data elements. Here also ordering is based on the arrival of elements and removal of elements. In queue, insertion and deletion operations are known as NQ and DQ, and insertion and deletion operation takes place at rear and front end. In queue, the element which is inserted first will be removed first. Because of this reason, we can say queue is following P4 data structure, that is first in first out order. We can classify queue into three categories. One is circular queue, deck, third one is priority queue. Circular queue. In circular queue, elements are arranged in a circular fashion. In a queue, once the rear pointer reaches the end, then the insertion operation is not possible even though empty room is available at the front. So this advantage is overcome by circular queue. Deck. In deck, both insertion and deletion operations can be made at both ends. Deck is used as a stack as well as queue. We can classify deck into two categories. One is input restricted deck, second one is output restricted deck. In input restricted deck, insertion operation is allowed at only one end, but deletion operation is allowable at both ends, that is at front and rear also. Output restricted queue. So in output restricted queue, deletion operation is performed at only one end, but insertion operation can be performed at both rear and front end. Priority queue. In priority queue, each element has been assigned a priority. Based on the priority, insertion and deletion operations are performed. So as far as the topics we have covered are what is data structure, what are the different types of data structures, what is the necessity for data structures, and a brief description on linear data structures. Thank you.